Oh, you're going to notice this. My handwriting's not the best. So if we're like trying to figure out what things are, let me know. This is what my X's look like. My Z's have a line through it, so it doesn't look like a two. I usually put a tail on my Y, so it doesn't look like an X. These are things I picked up as a student because I would go back in my notes and be like, what am I writing here? So you'll see things like that. All right, so very first four sections we're going to look at is just simply solving linear equations in different types. One step, two step, multi-step, letters on both sides, parentheses, and then we'll get into, hopefully at the end of the day, how to do word problems or what we call literal equations, which is just given like an area formula and you're just trying to solve for the length or something like that. All right, so we'll start off with the solving linear equations. And they're going to be in the form of either x plus b equals c, or they're going to be in the form of a times x equals c. Main rule of algebra that pretty much works for everything. If you are trying to solve for x, whatever you do to one side, you must do to the other side of the equal sign. And then if you're trying to get rid of something, just do their opposite operation. So if you are adding, the opposite of that is subtracting. And vice versa. So if I'm subtracting, the opposite of that is to add. The other one is if I'm multiplying, the opposite is to divide. And if I'm dividing, then I would be multiplying. Right? So that's pretty much the main thing. And then we'll get a little progressive with some roots and whatnot. But that's the main gist. Two rules, whatever you do to one side, you must do to the other. And to get rid of something, just do the opposite of its operation. And you can do that in many ways. There are sometimes shorter ways, and there might be ways that you can see, and you just go about that process. I'm going to be honest with you. The best way for me is I like to get rid of my constants. So I like to get rid of any addition or subtraction first. And then I'll deal with my multiplication division. I try to avoid fractions until the very last thing. I don't want to have to deal with fractions the whole time. So I'll show you also some techniques on what we can do to get rid of fractions until the very end again, just in case you start with fractions as well. All right, so there we go. So the very first type of your homework you're going to see is you're just going to determine if something is a solution. All right, so here's our first example. So in this case right here, we have x plus 3 equals 12, and you are given x equals 4. So determine if this is a solution or not. You just have to take this value here and just replace the x with it. So in this case, does 4 plus 3, what does that give me? 7, which is not 12. So this would be a no. That's the very first part of your homework. You're just trying to determine if something is the solution to it or not. So you're not having to solve it, you kind of having to evaluate. I did also forget in the syllabus, you are allowed a calculator, a graphing calculator. TI Nspire is what I will use when it pops up, but TI-84 is just as good or any other calculator. Yeah, I got that app as well. So sometimes I'll throw the Nspire way to do it. So you are allowed a graphing calculator. So by all means. And then the next one, let's try a different one here. We have y plus 3.7 equals 4.2 given x equals 0.5. Oh, not x, that's a y. Never understood why they always want to keep switching up the letters. Just keep one. It means the same thing. So again, what I'm going to do here is I'm going to take this 0.5 and I'm just going to replace that y with it. So this gives me 0.5 now plus 3.7. And what is basically $3.70 plus 50 cents, 420. So this would be 4.2. And so this would be a yes. Questions so far? Alrighty. And then it does get in to a few other different ones here I saw. There was a 4.3 minus z equals 2.1, given that z is equal to 2.2. So you'll be able to subtract as well. So again, I'm going to take this value, I'm going to replace the z with it. So 4.3 minus 2.2. Good. And again, the way we do this is I actually learned the vertical method. So I'll line up my tens place and my ones place, and then I'll start subtracting. So 3 minus 2 is 1, 4 minus 2 is 2, and then I bring the decimal down, so I see it does, in fact, give me 2.1. Okay. And then, of course, if you have to borrow, you just decrease 1, bring it over, if that's the concept that you have to do or not. Nowadays, what the kids learn, I really struggle. I have a son that's in second grade and a daughter that's in fourth, and I'm like, like a math teacher, and I'm like just scratching my head, like, y'all making this way harder than it needed to be. I love it. There is one more type, and I think this is an assumption they assume you know when you come into this course. But do y'all know what these bars right here mean? When you see these bars around a letter, absolute value. Absolute value. So I'll write a little note here. Best way I can describe this is distance from zero. You ever measure distance with negative numbers? No, a tape all has positive numbers. So we're 6 feet tall. Even if we dig a hole, it's 6 feet down or whatever it is. It's everything is measured in positive numbers. So what this basically means is whatever values put in here, the result's going to be positive when it comes out. So positive stays positive, or you plug in a negative and it comes out back positive because it's always the distance from zero. And I'll give you an idea what I mean by that. If I have zero right here and I have 2, how many numbers is 2 away from zero? 2. But if I have negative 2, how many numbers from zero? Still 2 numbers. So regardless of it's positive or negative, my distance will still be positive, right? So that's what I mean by that right there. So this right here is given now that y is equal to negative 7. So when I plug in this negative 7 here, what's the absolute value of negative 7? Positive 7, because negative 7 would be 7 numbers from 0. So this is really 7 plus 2, which gives me 9, which is then a yes. So I saw that on the homework, and I was like, ooh, that's an assumption they assume you already know coming into the course. Let me go over it. Yeah. Go ahead. You had a question? Yeah. So basically, the moral of the story, anything that goes in here will always come out positive. So even if I was just going to say the square root of 7, it would still be 7. That's all that means. Mm-hmm. Yeah. Good so far? All right, so that's the first part. And then after that, the rest of it is simply solving. I say simply, but it's a lot of sections doing the same task. Let's get right into it. All right, so the next problem here, we're just going to solve pretty much every one of these. So you start off with x minus 5 equals 12. So I told you there's 2 rules. You can do however you want, but whatever you decide to do to one side, you have to do to the other. And to figure out what we're going to do is we need to figure out how or what is the opposite operation of what's being done to the x. So currently I have an x minus 5. What would be the opposite of minus 5? Plus addition, right? The plus 5. So what I'm going to do is I'm going to add 5. But if I decide to do it on this side of the equal sign, I must also add 5 to the other side. Right? I can do whatever I want. I could have added 17 if I wanted to, as long as I do that to the other side. Now, adding 17 wouldn't give me x by itself, but I could go through that process if I wanted to. Now, from here, I just simplify. We now know negative 5 plus 5 would equal what? 0, which was the sole purpose of doing the opposite operation. So I just have an x equals, what is 12 plus 5? 17. So we're good there. All right. Next example I saw, you had negative 8 equals x plus 4. What do you think we're going to do to solve for x this go around? Perfect. Identify what's being done to the x, in this case, adding. So then the opposite of adding 4 would then be to subtract 4. But once again, since I did it to this side, I must do it to the other side of the equal sign. So that would 0 out. This is the sole purpose of why we did it. And now here's where it gets a little tricky. What's negative 8 minus 4? It would be negative 12. Yeah, so you are allowed a calculator, but this is what's going on. So let's pretend this is negative 8. If you are subtracting, you're going to go left on the number line. So this would be negative 9, negative 10, negative 11, and then negative 12. That would be 1, 2, 3, 4. Yeah. And negatives is what gets people. Negatives, fractions, decimals. Looking for an X. Yep. Yep. And yeah, and if you're adding, you would just go to the right of that number. That would be multiplication. So multiplication to negatives will give you a positive. When you are adding or subtracting, if they're both the same sign, it's just going to be bigger of that number. So in this case, they're both negative. So I'm going to get a bigger outcome. If they were both positive, I would get a bigger outcome. Mm-hmm. Uh-huh. Correct. And then you would end up with negative 8 plus 4, which would be negative 4, because now they're different signs. So I need to take the difference. And then the bigger number, that's the sign it would get. I like to think of it as money. But nowadays kids, they don't deal with cash anymore. So it's really hard to relate to them. But I like to go, all right, if I owe someone 8 and I borrow another 4, now I owe that person 12. That's how I like to think of negative money. All right. So now I'm like, all right, now I'm $12 in the hole with this guy, whatever the reason is. All right, next type. It does. Negatives do. And again, full transparency, calculator it. Just negative 8 minus 4. I don't want you to stress about the little part of the math, because the big part of the math is going to get more complicated. So if we need to add, subtract, multiply, and divide in a calculator, no stress. It does not bother me at all. Do it. Yeah. Like I said, I like the Inspires. They're about 120 bucks. 84 can do the same thing. They're a lot cheaper because they're starting to become kind of obsolete. The regular old graphing calculator, small version, you can get one for 20 bucks as well, just as good, as long as you know what all the buttons do. The version that the book shows, I believe, is an 84, and the version I show will be an Inspire. So you'll have a couple of those different versions as well. I will say another program that will help you like on your homework, but you won't be able to use it on the test, is like Desmos or GeoGebra. Those different type of apps as well are different ones you can use. I would practice what you are allowed on the test. So I would use like some type of graphing handheld calculator. And if you're worried about, I do Inspire. So it's a TI Inspire. It looks like this. They're a good one. I bought back when I was a kid. I bought an 84, and I used it through all my high school, throughout all my college. I tried to turn it on a couple of years ago, and I think I left the batteries too long, so now I don't think the machine works anymore. Um, let's see, I'm gonna have to switch over here to this. So this is kind of what it looks like. So you have a Inspire, looks like this, give or take. Has a lot of fancy buttons. That's why I say a regular calculator will work too. Do try to find one that can at least graph, just so you're able to have that advantage as well. But the calculators are no longer, just the regular four functions. You're more than welcome to bring that too, but definitely get a graphing one as well. But I love these things. I've used it now for 9 years, I guess. When I got introduced to me. All right, let's go back. All right, so the next type of problem comes in with some decimals. So we get x minus 3.7 equals 0. What do we think our approach here will be? Add. Good. The opposite of subtracting will be to add 3.7. But once again, what I do to one side, I must do to the other. So 0 plus 3.7 gives me, very good. I will say a lot of students will tell me 0 because they try to multiply this at this point. Make sure you're adding, not multiplying. Know what operation you're doing. A lot of students too, when it does come to like a positive, they won't write the plus sign. They'll just write a 3.7, and then when they write it over here, now they get confused on are they multiplying or adding. So keep the operation with the number so that you always know what operation you're doing. Alrighty. And then of course it wouldn't be a math class if there wasn't fractions. There we go. So we got x minus 3/8 equals 3/4. I can show you the way I would do this if I had to do this by hand. If you're allowed a calculator, again, I would just plug it in with the fractions and stuff like that. But for my starters, how do I get x by itself here? Good. My operation here is subtracting, so the opposite of that will be adding. And just because it's a fraction doesn't change the way we do it. So this will all go away. So to deal with fractions, to be able to add them by hand, the denominators have to be the same. So 8's my bigger number. So I'm going to look at my smaller number. Is there a way to make 4 turn into an 8? I can times it by 2. So I'm going to multiply this by 2. But just like equations, fractions are treated the same way. Whatever I do on the bottom, I must also do to the top. So now this becomes 3 times 2, which is 6, and 4 times 2, which is 8. The purpose of this is this denominator and this denominator has to be the same. And when the way we add fractions is once the denominators are the same, you just write that denominator. You don't actually do the operation on the bottom of the fraction. The operation is applied to the top. So this becomes now 6 plus 3, which gives me 9. So the answer here is 9/8. I'm good either way. I actually personally love improper fractions. They look cleaner to me. But if you want it to be a mixed fraction, you can make it a 1 and 1/8 if you want. If you wanted a decimal, what is that going to be, like 1.125 or something like that? I'm okay either way. Yeah, yeah. Improper to me looks cleaner than all the rest. But again, a calculator would easily spit that back out to you. And plus, it'll also spit out the simplified version because that's another big thing, especially on your Hawks Learning stuff. If this would have been like 18/16 or something, I would have to realize that, oh, wow, I need to divide both sides by 2. And we'll see some problems like that later. Right now, 9 and 8 have nothing in common, so I can leave it like that. All right. All right, so we're good on one-step equations. All right. Let's get into some more complicated stuff. So this is now going to be 5z minus 4z plus 3 equals 5 minus 7. I always love that meme where it's like you get a question like this on the in the class, and then you get a question like this on the homework, and then on the test it's like, if the star flies over the certain part of the sky, what color is the crown that you're going to pick up or something like that. I will say sometimes it does feel like that, but I will say the homework, this and the test to me look all the same. To me, I've never seen surprises. My students have never said there was a surprise. I always like to ask, do you feel like the test is fair? And they go, yeah, we saw all of this before. And so if they got it wrong, they just didn't know how to do it, but they saw it. So kind of keep that in the back of your mind. All right. So with problems like this, what makes it a little bit more intense is you have to combine like terms before we can start moving things across the equal sign. So here I notice I have a Z and I have a Z. So they both have Z's, so I can combine them. When I say combine, I'm basically saying you need to either add or subtract their coefficients, which are the numbers in front of these letters. So in this case, when I say combine these Z's, I'm basically stating what is 5 minus 4? 1. And so that means I have 1Z. Now, I wouldn't count off for this. I don't think Hawks Learning will either. But if you're left with a 1, you don't actually need it. It's just a Z. It's known that there's an imaginary 1 right there. Okay? If you write a 1, I'm not counting off. And I don't think Hawks will either, but for future classes, just kind of keep that in the back of your mind. All right, so I dropped the +3 because I couldn't combine anything else, but I do have what I like to call constants. Constants are numbers with no letters. So I can combine those again by either adding or subtracting. In this case, I have 5 minus 7, which is -2. You have $5. You want that purse that's $7. You still owe the clerk $2. Now I'm back to a one-step equation. So what operation is being done to the Z? Good, it's being added, so I need to subtract the 3. And just like before, what I do to one side, I have to do to the other. So -2 minus 3 gives me -5. Very good. Again, you owe someone $2. You borrow another 3. Now you owe them $5. So we're good here. All righty. All right. I must have missed something. Oh, I did. All right. Same process, but with decimals. We get 4Z plus 0.8 minus 3Z equals 3.1 plus 1.9. All right, so just like before, first thing I need to do is combine like terms. So I notice there's a Z here and a Z here. So what is 4Z minus 3Z? Ooh, 4 minus 3? 1Z. So this would be like I had 4, something cost 3, so I got $1 out of it. And again, this one here, we can simply plug 4 minus 3 if we need to. And then again, I'm not going to count off you put the 1 if it helps, but just know that's not really there. And then from there, I'm going to drop down that 0.08. And then now I can combine these like terms. So 3.1 plus 1.9. And if you're old school like I am, I'm going to do this vertically. I'm going to add the tenths place. So 1 plus 9 is 10. So I put the 0 down, I add my decimal, and I rise the 1 over there. And then I combine these. So 1 plus 3 is 4 plus 1 gives you 5. Now, because it's an even 5, I don't have to worry about that 0.0. I can just write 5. If you want to write 0.0, you're not wrong by doing that. That just tells the reader that you're just more accurate with your results. Now I'm back to a one-step process. So what do I need to do to get z by itself? There it is. So I'm going to subtract 0.8. And so what would 5 minus 0.8 be? There it is. So if I have $5, I spend 80 cents. I still have $4.20. We don't necessarily have to write the 0. Again, I wouldn't count off. You're just more accurate in that result. So we're good here? All right. Let's get into some multiplication and division now. So number 8 here, we have 3x equals 33. A number next to a letter is going to indicate multiplication. So then the opposite of multiplication is division. So I'm going to divide by 3. But if I divide this by 3, and by the way, a fraction bar means division. We don't really use this sign anymore. So but one thing that was cool, it was pointed out to me, I think last year, this actually looks like a fraction. Like you have a number, fraction bar and a number. I never even noticed that until last year. I've been doing this forever. But nowadays, you're not going to see this operation. You're going to see fraction bars and need to know that that means division. Okay? But of course, just like before with adding and subtracting, if I divide here by 3, I need to also divide the other side by 3. This right here becomes a big old 1, which is just an x because we don't necessarily have to write the 1. And then what is 33 divided by 3? 11. Pretty good. All right. So then they take that and they go one extreme. They can then go into a question that looks like this. So we got 2.5 x plus 0.4 x equals 15.2 minus 3.6. Yeah. I like having questions like number 8, but then that's not the. I want to make sure y'all get what y'all see on the homework because it's gonna suck. We only do one step, and then you're like, that was nothing we did in class. All right, from here, just like before, we're gonna combine like terms. So I notice I have an x and I have an x, so I can combine these guys. So what is 2.5 plus 0.4? Very good. 2.9. It's like $2.50 plus another 40 gives me $2.90. Biggest thing too, I've seen, this isn't not going to confuse you right now, but it will later. When I'm adding, notice it's the x is staying in x. A lot of students, when I teach you some other things, are going to start wanting to make that an x squared. Not the case. I'm just adding or subtracting the coefficient. Whatever the letter is stays that letter. All right, so just kind of keep that in mind. All right, then 15.2 minus 3.6. Yep, and so what we'll do is notice now that this is me going old school here, but of course you'll have a calculator. But the 2 here is smaller than a 6, so I'm going to do what we call borrow. So this 5 becomes a 4, and then I bring over a 1 as like a tens basically over. So now this becomes 12 minus 6, which is 12 minus 6, 6. Good. I'm going to drop down the decimal, and then I now have 4 minus 3, which is 1, and then I just drop down that 1. So it's 11.6. I'm not saying you have to do this, but I want to make sure y'all are seeing that as well. All right, so now we're back to a one-step equation. So what do I need to do with this 2.9? Divide. A number next to a letter indicates multiplication, so I'm going to divide. And this is definitely where I'm using a calculator. However, this is kind of the same thing as 116 divided by 2.9. Go ahead. That's a great question. And a lot of students do that. So that's why I want you to pay attention to the adding and subtracting. So when we were subtracting, we did the opposite operation of adding. We didn't change the sign. We did the opposite operation. And if it was adding, we subtracted. So here I'm multiplying by 2.9. So I want to divide by 2.9. But that's a great question. A lot of students do that. Yeah, that is huge. A lot of students, they have the concept of, oh, I just changed the sign. No, 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 no. We're doing the opposite operation. So that's a great question. So again, I'm going to actually use a calculator, but this would be, let's see, 11.6 divided by 2.9. 4. Another way to do this, you could say 116 divided by 29, put it in the house, do a whole bunch of long division. I'm not asking you to do that unless you really want to, but the here is this 4. All righty. See, okay, let's get into a question. So this is number, I guess that was number 9, just erased on me. This is number 10. We have negative x equals negative 15. What do you think we're going to do here? Ooh. Like the idea of dividing. So if remember, there it is. So if we come back over here to these questions, when we were combining these, we said that there's an imaginary 1 there. We don't necessarily have to write it. So if I come back, there's actually like an imaginary 1 here. Let me do it in a different color. There's like an imaginary 1. So instead of dividing by negative x, I actually want to divide by negative 1. But I totally get you, but I don't want you to move the x there because now we're dealing with a whole different type of equation. And so by doing that, I do it to the other side. So this goes away. And then negative 15 divided by negative 1 would be positive 15. This is the concept of 2 negatives make a positive when we're multiplying and dividing, and then 1 goes into 15 times. So on this right here, the 2 negatives will be a positive. And then once you determine it's a positive, you really just have 15 divided by 1. So the old school way, we ask ourselves, 1 goes into 1 time, 1 goes into 5 times. So 1 goes into 15 times. Absolutely. Like with the whole negative concept. Okay. Let's do negative x. We'll call this extra for right now. I don't have a problem. We'll call it 3. What would I do here? There's like an imaginary 1. Basically, what it's stating is by not writing the 1, I'm saying there's 1x there, but I don't need the 1 because what's 1 times anything? Itself. So 1 times x would just be x. That's why we don't write it. But it's okay if you write it. And I think on the tests and the homework and stuff like that, I accept those answers as well. So now that I know it's a negative 1, what am I going to do? I'm going to divide because a number next to the letter indicates multiplication. So the opposite of that would be division. And if I divide it on one side, I must divide it on the other. Now, 3 divided by 1 is what? 3. But when I have a positive and a negative, now it's going to be negative. So the way I show kids is if they're the same sign, so if they're both positive or both negative, it'll stay positive. And if they're different signs, you'll get a difference sign, like the negative sign, kind of concept to think about. So if it's a positive and negative that you're either multiplying or dividing, the outcome will be a negative. But if they're both negative, the outcome is a positive. So we'll write a note. Multiply or divide. If you have 2 negatives, gives you a positive. 2 positives give you a positive. And then a positive negative or a negative positive will both be negative. That's kind of your rule book there. So if they're the same sign, that answer will be positive. that's multiplication too. So if I was doing a negative number times a negative number, or a positive number times a positive number, or a positive times a negative, or a negative times a positive, same concept. If they're the same sign, it's a positive answer. And if they're different signs, it's a negative answer. All right. All right, so I'll keep this for a little bit, and let's do number 11, which comes back with fractions. Actually, let me write it like you'll see it. It'll be 2x over 3 equals 4/5. When you are dealing with fractions, the best way to get rid of this is multiplying by the reciprocal. The reciprocal, in what I like to call layman terms, just means flip the fraction. So if it's 2/3 here, I'm going to multiply by the reciprocal by flipping this fraction to 3/2. Notice the x didn't move because I don't want the x to move. I want the rest of the numbers to move. Now, the sole purpose of doing this is, what is 3 times 2? 6. And what's 2 times 3? So therefore, what's 6 divided by 6? 1. So it all goes away. That's why we multiply by the reciprocal. But of course, just like the main rules at the beginning, if I multiply this side by 3/2, I must also multiply this side. And to multiply fractions, again, you just multiply straight across, top to top, bottom to bottom. So 4 times 3 would be 12, and 5 times 2 would be 10. Now, this is where you get into some waters, because this right here is not simplified. What does 12 and 10 both have in common? A 2. So now I'll bring that division sign for you. We'll divide both sides by 2. Right? Because as long as I do one thing to one side, I have to do it to the top as well. So now 12 divided by 2 gives me 6 and then 5. So that would be your final answer, not the 12/10. So when you deal with a fraction like this, multiply by its reciprocal, which means just flip the fraction. Now, some professors teach this in a two-step manner. And what they'll do is, well, technically you're dividing by 3, so they'll multiply both sides by 3. And then they'll be multiplying by 2, so then they'll divide by 2. And that just seems, they say, too many steps when you can just multiply by the reciprocal. We're good here? All righty. And then there's one word problem on your homework. So I'm going to kind of condense this down. So number 12, you're going to be told there's an original price of a wool coat that was reduced by, so reduced price of, by $15.80. So again, a wool coat that was reduced by $15.80. The new price is $84.79. Now, what's really nice about it, it actually helps you develop the equation. So you don't have to worry about trying to figure out what the equation is, because that's another process that we have to go through. But they'll tell you, now solve this equation. So y minus 1580 equals 8479. Now, I do want to talk about this. You didn't have to write the equation. The equation is going to be given to you, but make sure you kind of understand what's going here. You're trying to figure out what is the original price if it was reduced by $15.80. So if you're shopping and you got a deal that's $84.79 and you know that it was reduced by $15.80, you can tell whoever you bought the item for, it was really this much, but you can keep the savings to yourself, right? So from there, how would I now solve this equation? Just add it. The opposite right here is it's being subtracted, so the opposite operation is to add. And again, these type of problems, I'm either using a calculator or I'm going to kind of go through it. 9 plus 0 is 9. 8 plus 7. Bring down my decimal. 4, 5, 10. Bring down the 0, bring it over, and you get 100. Well, 10 more. Yeah. So the original price there was $100.59. Got it for sale. Got it for $84.79. So any questions on our first section? So that's what your first set of homework looks like. All right. Let's take a 5-minute break. If we need to go potty, debrief, let's separate our minds. And then 9.2 is really just more of this.